All right, you guys, we'll be tackling example 16, which pertains to more of those segment and angle proofs that do not contain anything about solving for x. So we kind of have to use those nifty definitions, theorems, postulates that you have on that note sheet to help us prove that 1 is congruent to 3 when we're given that 4 is congruent to 5. So it's going to be a blast, you guys. The more proofs that we do, I promise you, the better it will get. So we're going to get through it. So let's just take it one piece at a time. So I know that angle 4 is congruent to angle 5, which angle 4 is this larger angle, and angle 5 is also this larger angle. Okay, you guys, what do we always write first in our proof? We do write the given, which the given states that angle 4 is congruent to angle 5. Nice. Okay, so I'm given something about angle 4 and 5, and then I'm trying to prove something about angle 1 and 3. Okay, which if you guys notice, angle 3 lies within angle 4. And angle 1 lies within angle 5. So I need to introduce angle 1 and 3 into the problem somehow. If I'm going to prove that they're congruent, they need to show up somewhere on my proof. Okay, so since I know that 3 is inside of angle 4 and angle 1 is inside of angle 5, maybe if I break down angle 5 and 4 into their smaller pieces, their smaller angles, that would be a good way to introduce 1 and 3 into the problem. So I'm going to do precisely that right now. Okay, so I know that the measure of angle, well actually before I do that, okay, I'm going to skip a line and I'll explain why. I'm going to say that the measure of angle 4 equals the two angles that are inside of angle 4. Which two angles make up angle 4? Holy hot dog, it is angle 3 and 2. So that will equal the measure of angle 2 plus the measure of angle 3. All right, and which two angles make up angle 5? Well, I know that 5 is made up of angle 1 and angle 2. So this will equal the measure of angle 2 plus the measure of angle 1. Okay? Now, what is that reason? Which I know I left this blank. You're probably like, Miss Long, what are you doing? You skipped a step. You're bothering me. Well, I'm going to address what we need to do in this step, but I'll do that in a little bit. Okay, so let's think about our reason. What is that lovely theorem, definition, or postulate that we use when we show that a larger angle equals the two smaller angles within it? Or when we add angles together to get the larger angle. What is that called? You guys are too cool for school. You guys always know the answer. It is the angle addition postulate, since we're dealing with angles. So angle addition postulate. Gotta say it fancy like that. Angle addition postulate. You have to say it fancy. So anyways, the reason why I skipped a step, if you guys see here, I have equal signs in my problem. I started out with congruent signs. So if I am going to use equal signs, I need to transform my congruent sign into an equal sign. So that will be actually the second step in the problem. So I'm going to say the measure of angle 4 equals the measure of angle 5, because if two angles are congruent, what that means is that their measures are equal. Okay, if two angles are congruent, then their measures have to be equal. So I'm describing the word congruent. So if I'm describing a word, what am I doing with that word? Holy hot dog, you guys. I am defining the word. So I'm defining what it means to be congruent, which means if two angles are congruent, their measures are equal. So this would be definition of congruent or congruency, or congruence, whatever you want to say. Congruent, congruence, congruency, all means the same thing. So definition of congruence. Yay. Okay, well, let's keep going now. Also, you guys, the reason why I know it's definition of congruent, anytime you change a congruent sign into an equal sign, or vice versa, when those transform to be the other one, okay, we are using definition of congruent. So when congruent changes to equal, or when equal changes to congruent, definition of congruence. That is always going to be what that will be. Okay? All right, let's keep going. All right, now, so I know angle 4 and 5 are equal, and I've broken down angle 4 and angle 5 right here. Okay, so what I'm going to do in the next step, I'm going to combine these two steps together to get my next step. Okay, so I'm going to write something. You technically don't have to write this, but it kind of explains what I'm doing. So, really small, I'm going to write this line again. The measure of angle 4 equals the measure of angle 5. Okay, in this step, I explained what the measure of angle 4 and the measure of angle 5 are. What does the measure of angle 4 equal according to this step? Well, the measure of angle 4 equals the measure of angle 2 plus the measure of angle 3. So I can replace the measure of angle 4 with the measure of angle 2 plus the measure of angle 3. All right, and then what does the measure of angle 5 equal in this step? Nice job, you guys. It does equal the measure of angle 2 plus the measure of angle 1. Okay, so all I've done is I've replaced 4 and 5 in this step with what they equal. 4 equals this and 5 equals that. So what is it called when you replace things with what they equal? Okay, so who replaces me when I'm out and I'm not at school, or they try really hard to replace me? It is a substitute. So we are using the substitution property because I'm replacing 4 with what it equals and 5 with what it equals. So I'm definitely using the substitution property. Okay, also you guys, this could be a form of the transitive property because I could say it like this. Okay, I could say if 2 plus 3 equals 4 and 4 equals 5 and 5 equals 2 plus 1, then 2 plus 3 equals 2 plus 1. So it's also kind of a form of the transitive property. If A equals B and B equals C and C equals D, then A equals D. So you could also use the transitive property in this one. Whichever one floats your boat. Okay, you guys, we're getting closer. So now I have 1 and 3 in my problem, definitely. Okay, and I want to show that they are congruent, which again means their measures are equal. So I want to show that 3 and 1 are congruent, or their measures are equal. But currently, these 2's on both sides of my equation are getting in the way. They're bothering me. They're irking me. I need to do something about these 2's. What can I do on both sides of my equation to annihilate and get rid of the 2's? It's going to be kind of violent. We are going to subtract by 2 on both sides. So I'm going to subtract by the measure of angle 2 on both sides, which will cause both of these to cancel out. Bam, 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 bam. Go away. Okay? And then what I'm left with is the measure of angle 3 equals the measure of angle 1. So, since I subtracted on both sides of my equation, what property did I just use? Like normal, you guys are correct, correctamundo. Okay, this would be the subtraction property. Subtraction. Okay, you guys, so we're getting really close. I'm trying to show that 1 and 3 are congruent. Right now I have that 3 and 1, that their measures are equal. Okay, so I need to get my congruent sign back into the picture because I changed congruent to equal, but now, since I'm ending with congruent, I need to switch back to congruent. So in the next line, all I'm going to do is transform my equal sign into a congruent sign. So I'm going to say angle 3 is congruent to angle 1. All right, and just like up here, what it means to be congruent is that if two angles are congruent, if two angles are congruent, then the measure of the angles will be equal. So what is it called when we change an equal sign to a congruent sign, or a congruent sign to an equal sign? Just like before, it is definition of congruence, which you are allowed to use the same reason as many times as you need to. It's not like, I've already used definition of congruence, so I can't use it again. That is not a rule. Okay, you're simply just explaining your reasoning. So if you have to do the same step more than once, then you have to. So definition of congruence, or congruent, or congruency. Okay, we are really close, you guys. Like, I can see the light at the end of the tunnel. We're so close. Okay, so I'm trying to prove that 1 and 3 are congruent. Currently, I have that 3 and 1 are congruent. And I'm trying to prove 1 and 3 are congruent. Okay, so if 3 is congruent to 1, that technically means that 1 is congruent to 3, but mathematicians can be kind of sticklers every once in a while. They kind of have to be really nitpicky at times. So when we do a proof, we must end our proof exactly as it looks. If it doesn't look exactly like this, then I'm not done. Okay, so now I'm going to force this thing, whether or not it wants to look like that. I'm going to be a little mean, sorry. Okay, so I'm going to flip this thing around my congruent sign. So I'm going to say angle 1 is congruent to angle 3. So do you guys remember what is the property we use when we can reverse or flip around a congruent or equal sign? Well, this might make it clear, which you don't have to write this down. Okay, so originally I had 3 was congruent to angle 1 in this line. Okay, and then in this line I have that 1 is congruent to angle 3. What is that property called when it kind of has symmetry when we go from one step to the next? If you see here, I could like flip this thing over that line of reflection. What is that called? Nice, you guys. Awesome sauce. It would be the symmetric property. Okay, you guys, we have reached what we were trying to prove, and we're super excited. So again, we express our happiness with a happy face. And I'm going to also do a cat because I really enjoyed this problem. I'm going to give it a little top hat because it's cute with the top hat. So there you go. There's my cat's top hat. Nice, you guys. It's also going to have a bow tie because it has a top hat. It's got to have a bow tie, right? All right, way to go, you guys. That was great. All right, you guys, we'll be tackling example 16, which pertains to more of those segment and angle proofs that do not contain anything about solving for x. So we kind of have to use those nifty definitions, theorems, postulates that you have on that note sheet to help us prove that one